Hello, everybody. Welcome to Chapter 5. So Chapter 5 is all about solving systems of equations. So I already have it written down for you, so you guys can pause this after I'm done explaining it and just write down these definitions. So a system of linear equations consists of two or more linear equations with two or more of the same variables. So we can have, what we're mainly going to be dealing with is two equations consisting of two variables, but you can have three equations consisting of three variables and so on and so forth. But for the most part, what we're going to be doing is solutions to a two variable system is always going to be an ordered pair x, y. So those are always the answers that we're looking for. We have to have the x value that works and the y value that works in order for them to be a solution. So you guys can pause it there if you want to write that down. And we'll go on to our first example. So our first example is determine if the ordered pair 5, -1 is a solution to this system that I gave you right here. Now again, if this is going to be a solution, this must work and be true for both equations. So we're going to just make a note of that here. So must be true for both equations. All right, so when I'm going to plug this in over here, I want to make sure that it's true for both. So the first one I'm going to do it in green. And again, if you want to label these up here, this is your X, this is your Y. So if we're trying to figure out if this is true, we're just going to plug it in. So I'm going to have 2 times 5 plus 9 times -1, and this should equal 1. So 2 times 5 is 10. 9 times -1 is -9. That should equal 1, and it does. So for this one, we're off to a good start. All right, now, but that's not good enough. If it works for that one, it's a solution to that one, but what about this one? So we still have to double check that one over here. So now I'm going to have 6 times 5 minus 7 times -1, and this should equal 14. So 6 times 5 is 30. -7 times -1 is positive 7. And then this should equal 14, but it doesn't. So 37 does not equal 14. So this is not a solution to the system. It worked for one, but not the other. So our final conclusion is not a solution. Okay, so that's one way to just determine if it's a system. So when you guys are taking a test or a quiz and you're like, I think I got this answer, but it doesn't seem quite right, you can always plug in your solution to any system that you get. And if it works for both of them, that means you know you did the problem right. All right, let's actually go on to graphing. Okay, and again, you guys can pause this and write down this system. And then what I do here is I usually just color code my lines just so you guys can tell which one is what. So I'm going to make this top line a green one. So notice this top line is already in slope-intercept form. It's already set to graph. So I can just go ahead and graph this one. So remember, you're always starting at your B. That's always your starting point. It's your y-intercept. So we're always starting on the y-axis. And then our slope over here is -1, or you can put it -1/1. Just make sure negative means you're always going down, and then you always go to the right at first. So if it's negative, down and to the right, down and to the right. And again, for these systems, I don't quite know where they're going to cross, so I want to try to fill in as much space as I possibly can. And as you notice, when I'm done going down and to the right, I can go up and to the left because up is positive, left is negative. So I'm still taking a negative turn. And this line should have a negative slope. So you can always double check for that and just make sure you're doing it right. So this is my first line. But then over here, my second line is not in slope-intercept form. So I have to put this into y equals mx plus b. So I'm going to subtract the 2x. You guys should be really good at this over here. Make sure when you're subtracting that 2x, this y is still negative. If you don't pay attention to that, you're going to get this problem wrong. So now I have -2x minus 1, but now I still have to get this y positive. So that means I have to divide everything by -1. And whenever I divide everything by -1, all that does is just change the signs around. So everything was negative before, dividing by -1 makes everything positive. So now this is the new line that I'm going to graph. So again, I'm going to start at my B, my y-intercept. So just start at 1 on the y-axis. And now my slope is positive 2 over 1. So now that means I am going up 2 and to the right 1. And look at that. Right off the bat, I run into my other line. And then if I did want to keep on going down 2 in the left one, but I already know where they're going to cross. So I don't have to go fully over here, but I am going to extend my line throughout this. Okay. So, and again, this is how you graph it, but I still didn't even state my answer yet. Remember, my answer has to be an ordered pair. So my solution is going to be, what is the only ordered pair that is going to make both of these lines true right where they cross? So this is going to be 1, 1, 2, 3. So my solution is the ordered pair 1, 3. And again, if you are ever unsure if you did that right, just plug them back in over here. So my y is 3, so -1 plus 4 is 3. 2 times 1 is 2. 2 minus 3 is -1. So you can always double check and make sure they're right there. Okay, moving on to the next problem. Okay. So now both of these ones are in standard form. So I have to do a little bit of math before I can graph either one of these. So I'm going to start with this top one. I got to add my 3x over to both sides. So now I'm going to have, 2y equals 3x plus 4. Divide everything by 2. And this equation is going to be y equals 3 over 2x plus 2. Okay, so I'm starting at my 2 on my y-axis, and then I have a positive 3 over 2, so I'm going up 3 to the right 2. And then if I run out of space going this way, I'm going to go down 3 to the left 2. And again, I should have this nice positive line. I'm going to fill in as much as I can because I don't know where this other line is going to cross it. Okay, and then I got to go on to the next line. All right, so this one, again, I got to put it into slope-intercept form. So I'm going to start by adding the 6x. So I have -4y. Again, this sign is often overlooked, so make sure you're always paying attention to that. Equals 6x plus 8. Divide everything by -4. Hold on, I think I made a mistake in this one. Oh, I did. Originally, I'm sorry, it's just the way that I wrote it. And I do need it to be this way. This was supposed to be a positive 6. So I'm going to change this to subtracting. And you'll see why I'm doing this in a second. I apologize. Okay, so I'm subtracting the 6x over here. So this guy is going to be negative. Okay, so now, if this guy is negative, I'm going to have y equals. So now I have a -6 over -4, which a negative over a negative is going to be positive, and you'll see why I did that in a second. And then 6 over 4, I can simplify into 3 over 2. I can divide both of those by 2. So I have positive 3 over 2x again. And then positive 8 divided by -4 is now -2. Okay, so these equations should look very similar. The only difference is this was a positive 2 and this is a -2. So for my pink line, I'm starting at -2 on the y-axis, but I'm still going up 3 and to the right 2. And hopefully by now you are seeing why I had to change that one sign just to give you this example. And you should have hopefully seen it as soon as we simplified this. As long as I have the same exact slope, that means that these lines are going to be parallel. Okay, so if I have parallel lines, then the question becomes, what's going to be my solution? What ordered pair is going to make both of these guys true? And if they do not cross, that means they have no solution. So these ones are no solutions. Parallel lines never cross by definition, so they are no solution. So that's why I had to change that one sign just to give you that example. Okay, one more example for solving systems by graphing. Our top line we have to put into y equals mx plus b. The bottom line is already there, so that's nice. So I'm going to subtract my 8x first. I have 6y equals negative 8x minus 6. Divide everything by 6. And y is going to equal negative 8 over 6. I can simplify that by 2 again. So I'm going to have negative 4 over 3x. Negative 6 divided by 6 is just going to be negative 1. So always simplify your fractions, just because when you go to graph this, you would still get the same line if you kept it negative 8 over 6, but the counting and your points in between, that's just going to be kind of a little silly. So you want to make it as simple as possible. So I'm going to start at negative 1 down over here. And then negative 4/3, so I got to go down and to the right this time. So down 4, 1, 2, 3, 4, to the right 3. So I ran out of space that way, so I'm going to go up 4 and to the left 3. And again, I should still have that negative line over here. Okay. So that's my green line. Now I have to take a look at my pink line. And wouldn't you know it? So I have y equals negative 4/3 x minus 1 again. So again, I'm going to start down here. Down 4 to the right 3 lands me here. Up 4 and to the left 3 lands me here. So this one is the exact same line. Okay? So this one's the exact same line. There is a name for these lines. They are called coinciding lines. Okay? So I'm going to just write that down over here. Coinciding lines. And that just means they're the exact same line. Okay, so coinciding lines mean the exact same line. But now, what's our actual solution to this? Where are they touching? They are touching absolutely everywhere. They're not just touching on like the points that I put in, but every single point in between here. So I can plug in like, again, I can plug in pi or something if I want. I'm probably going to get an irrational number for y too, but they are still touching at every exact same point. So this is where you have infinite solutions. And those are the only 3 possibilities that you guys can have when you are solving systems in general, but that's how they look when you are solving them by graphing. So you're either going to have 1 solution, no solutions, or every single possible solution imaginable. Okay, so that's it for solving systems by graphing.